Okay, and we are back after Gavin got stuck in the last episode. So this is where we left off in the last episode. We were doing this proof that 9 does not divide 192, and we managed to prove that's true if 192 over 9 isn't an integer, but then I got kind of stuck because I didn't quite know where to go from there. So I had a little dig around in the database, and I found this really good proof. Paul Chapman, 2011, very good. So it says if you have n is an integer, d is an integer, k is an integer, and k is less than d, then if d divides n, then it is not true that d divides n plus k for any k that's less than d, right? So basically what it's saying is if n divides by 11, say, if you add 1 to 11, or 2 to 11, or 3 to it, or 4 to it, or 5 to it, right, then it still won't divide. So, okay, so 121 divides by 11, but you know that 122 doesn't, or 123 doesn't, or 124 doesn't, because you have to have a whole nother block of 11, right? You have to have a whole nother block of 11 to go up to the next divisor, right? So using this, I think we can arrive at the result relatively quickly. So I think what I want to do is I want to get rid of basically everything. So that was all a bit of a red... It was a good approach. It wasn't like necessarily a red herring, but it was just sort of not the best. And let's put that in. Oh, wait, yeah. Let's put that in like that. Okay, and this is the result that I want to establish. It proves that... So we have to put in what does work. So 9 divides 189, right? So that divides it 189. Okay, and then 3 more, that will bring us up to 192. Okay, so that's fine. I'm going to do that again. So I'm going to set the format number, and what the format number does is it stops all this weird indentation happening. So let's get rid of that. Okay, let's put that in. There we go, that's nicer. So we have 9 divides 189, and what we were looking for is 3 more. Okay, so we have this result now, but we have it with these conditions. So let's break out the conditions. 3000. I want to prove this. Formula contains parse errors. Okay, that's done pretty well. So it's done 3 is nn, 9 is nn, da, 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 da. It just needs 189 is in zz, and I think as before, we get 189 e.nn. Okay, and then that is done and doable. So those constructing these decimal numbers in nn is not so bad. And cool. Okay, so we've got these conditions. So then 4000, we can just have the result on its own. Implies this, I think, because we've done the conditions in 3000, so then we can have the result in 4000, and then what do we want to do? Okay, well, we want to... This isn't quite what we want, right? Well, in fact, let's do next. That would be quite helpful. Is to prove this is true. 9 divides 189. Okay. Let's have that. And I think we can use divslum, right? I think that's what we need. We need 9 and 189. Right, and that will be 21 times 9. Right, and then we just need to prove the beginning of this. I think it's only one bracket, right? It's 1 open and 1 close, and then 1 open. Oh no, times this equals that. So I think we need that. So if those things are all true, wow, okay. Look at MMJ2 go. You can't hold a good MMJ2 back. Okay, so it's basically done the majority of that work for us, which is great. It hasn't quite got here. So I think if we have 21 e.nn, yeah, okay, that's helpful. And then we can have, I think it's 9nn. Yeah, and then we just need 189 e.nn. Okay, and that fills all that in, which is good. So then we can have this as a theorem on its own, because we've already proven all its prerequisites. 50. Oh no, maybe it just needs to go lower down. I think that's the mistake I made, is that actually all of this is part of that too, right? Because it requires 21 times 9 is 189. So where's that? 21 times 9 is 189. Okay, so now let's put all the prerequisites together. So if I put that in as 1200, that should give me that. Good old modus ponens. And then I don't know if I think 9 to 189. I already have that, right? So 5,000. I then want to say it is not true that this, right? Because that follows from 4,000. Okay. And then we just have to have this. Maybe it needs the brackets. This equals 192. Yeah, and therefore this is true. Has it done all the proving of that? I think that's filled it all in correctly. And then 7,000. 189 plus 3. So we have 189 plus 3 is 192. So therefore, not 9, 192. So I think it needs one more step, right? And it's just because it's having a little bit of trouble linking those two things together. So then we say if and only if this. Right? And I think, yeah, that is enough. Because it said these two things are equal, and therefore these conditions are not equal, and therefore we get the result. So 9 does not divide 192, which is pretty cool. That is a cool thing to have proven, I think, because it's a bit more complex than just proving that it does divide, right? So we had to use a does divide in this in order to get it to work. But unfortunately, because I closed the browser, it deleted the question. So the alien's like, no, that's not good enough. We need to now know 1296 divided by 11. Okay, so they've changed the problem, which kind of sucks. So I have to do that then. All right, let's try that. So 1296 divided by 11 is 117. So exactly the same process. So let's start doing some deleting. Right, so we have 11. I wonder if this being a decimal will change anything. And then we have 1296. Is that right? 1296, 11. Okay, great. So we want to get rid of everything. The two key steps that we need are dvds0lem and that other one with dvds in it. Where did it go? That was it. ndvds, that one, add. Yeah. Okay, so we get rid of all this. we'll get rid of this, and we'll get rid of all this, and we'll get rid of that. Okay, so I think we should be able to speed through this. Okay, and this is obviously no use. Grammatical pass errors. Where? If we delete this too, does that help? Okay, let me have a new proof, just to check that there's not any kind of weird problems with the deletions that have happened. No, it doesn't like it. Maybe the not, does the not need brackets? I don't think the not does need brackets. Is it because 1296 needs 3 of these? Okay, very good. Right, okay, so what is close? So what we need is 117 times 11, right? So if you have 117 times 11, you get 1287. Okay, so 11 divides 1287, and then we get 11 divides 1287 implies that 11 does not divide 1287, right? And then to get up to 1296, I think I need another 9 plus 9. Formula contains typos, huh? Maybe I was a bit hasty. Is it that these only need 3? Okay, that is good. And so that will be 117 times 11, right? 117. Okay, so all we need to do is prove those two things. So let's go through the standard procedure. We can break out these conditions as individual, right? And it does all that. 9 is less than or equal to 9. Surely you can do that. Okay, to the 500. 9 is equal to 9. N is equal to N. Yeah, cool. Still can't do it. Still can't do it. 2600. 9RR. 9RE. Cool. 1287 members of ZZ. So we'll have 1287 E dot NN. Get a bit more used to this. And then that is filled in by all that. Good. Well done. Well done, MMJ2. Implies this. So I think we've arrived at having this on its own, right? Because we broke off its conditions and therefore it works. So now we just need to prove this. 11 divides 1287. So let's break off these conditions. That's not, yeah, that's why. There, I was worried about the brackets, but it's because of that. Okay, so we just need to prove these conditions. So call that 1100, well, 1500. Are you happy? Are you happy? Okay. Is there any part of that it's struggling with? No. Looks pretty good to me. It just needs these. So let's have 1100 117 e dot nn, and it's usually quite good at proving those. And we need 11 e dot nn. Cool. And one 287 e dot nn. With turnstile, it's provable statements. That needs a turnstile. Okay, so I think that's done all the conditions. So if we have these conditions be true, that implies 11 divides 1287. So that is here, I think. So 1600s, we can have this. Are you happy that that is true? Yes. Okay, so then we have 11, we have what we've just proven, which is 11 divides 1287. So 11 implies this. Right, 5,000. That is now true. So in a way, that's quite a lot of what happens in metamath is when you have something implies something else. If you can prove that thing, then you can kind of rip that off and just say, okay, now this thing is true on its own, which is quite helpful. And then we just need those last two steps of 187 plus 9 is equal to 1296. With brackets for addition. Stepping complete, but that's one of the ones that can do pretty well by itself. Cool. And so therefore, where was that? That was DVS add. Where was that last not divides? Yeah, there we go. XMP 11 does not divide if and only if, and that statement will need a bracket. The same thing is true, but with 1296. Here we go, ready for the final flourish. Put a couple of exclamation points in, and done. Ta-da! It's done it. All right, so that's really not too bad, and it was helpful that we kind of had the template of the one that we did before. So it was just the main points of the proof are to use this DVDS01lem to prove that one thing is divisible by another, and then we had the other DVD thing, NDVDS_add, to prove that if you then add on something smaller than the divisor, it doesn't divide, and then you get to the proof and you get the not equal to. Okay, so we are definitely sure that no, it does not. We checked that very, very carefully. Wolfram Alpha doesn't understand your answer. How can you not understand the answer when I'm clicking the no button? That seems really bizarre. All right, well, I guess that's it. You know, London's going to have to be destroyed. I'm sorry, the Wolfram doesn't accept the answer. Like, no, that's it. Everything's broken now. And I think if I refresh the page, this problem will disappear. So that'll be the end of it. All right, well, we lost the city, but I guess let's carry on. I will hope you enjoyed fun, and I'll see you in the next one. All right, bye.